if we have 1,000x more compute, things will get better significantly.
Okay.
The models will be better, they'll be more powerful, etc. Did we know exactly how? No, but like if you ask people in the space, 9 out of 10 would probably tell you yes. If they're much bigger, it'll be better. They might not have a more clear
Right.
scaling law or whatever, but it was very clear. So there was enough impact that this space was having that there was interest in making that happen.
Mhm.
It wasn't clear how to do it. Absolutely. Like you said,
Right.
right? Looking
Yeah.
back, it's easy to say this is where it came from.
Yeah.
Now, so looking forward, can we say this is where it's going to come from? It's going to be super hard, right? I don't think we
Yeah.
can nail down exactly where this 50x or 10x or 2x or whatever. The ones I put in the post were more learning from the past, and there's some areas
Right.
that are not as explored. For example, sparsity is just one of them. That happens to be my favorite one as well. But I don't know. I have no idea if that's really going to make it in, especially in the next 10 years, maybe in 20 years, maybe not at all.
Hi, friends, and welcome to a very exciting episode of Leading with Data. I have Rajat Monga with me today. So, Rajat is a IIT Delhi alumni, and he had co-created and led the team which developed TensorFlow. And some of the key decisions around TensorFlow, he was very involved in terms of the way it grew in the community. Post TensorFlow, he has started his own startup, Inference.ai. So there, I feel there is so much to learn from his experience, his days at Google Brain, the work at TensorFlow. So really looking forward to the discussion. Outside of work, Rajat is also an advisor at Plaksha Technology Leaders Program, which is one of the best programs in India, and he holds 3 patents to his name. He has been involved in our community. He was there at 1729 as one of the keynote speakers, and there is so much to learn from his perspective, his experience. So, Rajat, thanks a lot for taking time out for this, and welcome to the show.
Thanks, Kunal. Great to be here, and always a pleasure to talk to you.
Great. So, Rajat, I would like to start with your let's say early days in your career, and how did you get into data science, machine learning, and then what was your journey into this field?
Yeah. So, like you mentioned, I graduated from IT Delhi way back when, and it's been a while, I guess. So after that, this was the early days. This was 96. So
Mm-hmm.
software was a thing, obviously, but was still very, very early. Just to give you an idea, Infosys, which is the first company I joined, was less than 1,000 people when I joined it, and now it's what, a
Right.
few lakhs, I guess. So that's
Right.
grown like crazy. And
Mm-hmm.
that's been the state of software in general. So it was a great time to be
Right.
doing that. I spent a
Mm-hmm.
couple of years in Bangalore in 2, 3 different companies. Infosys was the first one, a couple of different startups as well. In all of these places, I was learning a variety of things. So I wouldn't say I did just one thing. In fact, I started with
Mm-hmm.
mainframes, did some desktop tools, etc., for a bit. Then I built some desktop applications, UI, backend, servers, whatever you name it, over the next few years. Continued to focus on the system side. I enjoyed that, but I was never limited to that. Like I built different kinds of distributed systems, but also wherever needed, would also build the front ends, etc. Right? So it's really
Mm-hmm.
learning across the board. Um, 99, I came to the US and to the Bay Area, have been here ever since, and done a variety of roles here. Again, early days, it was still startups. The fun thing about these startups was there's a very, very early stage. So I got to do everything from scratch, right? Which meant, and
Mm-hmm.
this was like when what's there on the internet today was not quite available, but still there
Yeah.
was tons to learn. I hadn't done these kind of large scale systems before, but I was forced to do it because there were only so many people out there. And so I just learned by doing and looking at what others had done, etc., looking at source code that people were doing, etc., as well. Anyway, a few years hence, 2009, after one of my startups, Attributor, I ended up joining Google. And so far, it was all kinds of systems. This last startup, I'd started to play with not ML per se, but similar things in terms of we were trying to find copies of content across the web. And while
Mhm.
text finding is similar to search, not quite the
Yeah.
same. It had different things, but similar ideas. Once you go to images and video, you need to start needing more things. So in this case, we needed different kinds of features, and this was pre deep learning days. So these were SIFT features and
Mhm.
things like that that you're trying to match up. So anyway, joined Google, building systems again in ads. Uh, 2011, I was exploring, wanted to do something new, and ran into Andrew Ng, who was giving a talk at Google. Him and Jeff Dean were starting to think about, what, deep learning is interesting. So far, people are running on just one box, and in fact, not even with GPUs. So the models are very, very small. What if we could scale them up? And Google had
Mhm.
both the compute resources and the data. And the promise
Correct.
was, so far, what they'd seen was if you grow these models, they're going to do better. And by the way, that hasn't changed so far, but
Yeah.
at that time, it was still early days, right? We hadn't seen any big impact yet. But seemed exciting. I had played with neural nets like way back in college, in fact, or
Mhm.
rather, not even played, just read about them because I was exploring doing them for one of the projects. We ended up not doing anything then. Was probably right. I mean, like they were too, it was too way too early then. But 2011, now we started building this. We built an internal system called Disbelief. We're able to scale from one machine initially to four, 10, hundreds, and then even thousands, and started to see very interesting results, right? We published some papers over the next year or two. And that was pretty amazing. We started to see real results where this could be applied. First one was probably speech, and then vision, and over time started to see a lot more. So that's
Right.
how, that's really when I got deeper into the ML side of things. Before then,
Mhm.
yes, I'd read bits and pieces, even in ads. Of course, ads always used machine learning for lots of things. So I would read
Correct.
bits and pieces, but I was never like into it. At this
Mhm.
point, because you're building the system from scratch, I had to learn things like backpropagation, etc., learn the math, I had to implement all of that. So it's like, okay, this is a good time. Let's take some courses. Andrew being here, he was great about, teaching us, taking the course. We had a couple of interns from his group who were also great about, I learned a ton from them and different kinds of things. Then over time, of course, just started reading more papers, more things, and there was more information available on the net as well over time.
Yeah. And you mentioned about scaling laws, and then obviously they are a lot more established now than
Yep.
they were at that time. So can you elaborate a bit on what was the feeling then, and then was uh, this already established that by doing or throwing more data and compute you could get better results, or that was still under research when you decided to take a plunge on this?
So it was still very, very early. Look, the scale, the biggest scale that then was still whatever you could fit on a single machine, no GPU with I don't know, maybe 4 gigs of RAM, 10 gigs of RAM, something like that, right? So
Yeah.
very limited. And how big a model can you train on a single machine? How long are you willing to wait for that? Uh, over the next couple of years, of course, once you got GPUs, you could do things a little faster. For example,
Mhm.
when we trained the speech model, we ended up training in two ways. One was there was an intern who was training this on GPUs, Navdeep Jetli, who ended up doing a lot of good stuff with that. And he trained that model for over a month on a single GPU. Whereas in parallel, we were running a similar model on hundreds of machines on CPUs because we didn't have GPUs in the
Okay.
data center still. And that,
Mhm.
again, it took months. So there wasn't really anything back then that showed us, okay, what it would be. That
Right.
said, even on very little benchmarks like MNIST and CFAR 10 or whatever, CFAR 100 and stuff, like uh, we were seeing early results on, okay, if the model is just 2 layers versus 4 layers or whatever, or 3 layers, it seems to get better. If we can put more parameters there, that seems to help. uh,
Mhm.
the techniques to train were still very limited in terms of when we started, you couldn't train the entire model from scratch together. You actually had to train it layer by layer. So you start with a single layer thing, then add another layer, then add another. So things were a lot more complicated. People hadn't figured out how to scale. People had the promise was there in two ways, I would say. One, that the
Mhm.
early thing going from like the tiny models that people had, the only successful deep learning model in some sense by then was the network from Jan LeCun basically that did the addresses or postal address codes, etc. Right from
Right.
these.
Right.
That's pretty much the only one that was successfully deployed in some ways. But that said, even going from there to the bigger ones, the quality seemed to improve. So
Right.
no laws, but it seemed directionally like a good thing. That was one. The other
Mhm.
was that was exciting was that this could be applied to lots of domains. The same
Right.
idea, very similar networks. The promise was you can take it and the same idea from vision to speech to text, and they might work. Right? Again,
Mm.
very, very early results, but was very, very
Right.
promising.
Interesting. And then some of the calls which you took as a team, right? So, for example, open sourcing TensorFlow and growing the community around it. What were some of the drivers of those calls, and then you how you went about those?
Yeah, yeah. So open sourcing was interesting, right? We one first our first system wasn't TensorFlow; it was Disbelief that was internal.
Right.
And this was very, very early, right? It was too tied into
Hmm.
the internal networks and the internal systems at Google, so we couldn't even think about this. Now, move
Hmm.
forward 3 years, 2014. We want to build a new system because the system is coming apart at the seams. We want to add GPUs, TPUs, um, RNNs, LSTMs, and we can patch them on the existing system or a new one. And we end up deciding, okay, let's do a new one. Now, from that point, though, a couple of months in, we are talking about things, and this was in fact Jeff's suggestion on, what, it's we should think about open sourcing it. And the biggest reasoning there was in the past, Google had published papers about the different systems. We published a paper about disbelief as well. But in the end, what happened was a few years hence, somebody would take that paper, try to make an implementation that's sort of like that, was never as good, but that
Hmm.
would become the standard. And as Google was getting into cloud, it was having to support those substandard or not as good implementations from outside their APIs, etc., on systems that we knew were much better, technically at least, and they could scale better, etc. The idea
Hmm.
was, can we actually set the standard in this case by open sourcing? So that was the biggest thing, number one. Number two was, if we have this outside, and this was the driving force behind building a community as well, can we help accelerate the speed of how AI is, evolving, etc.? Given that Google's at the forefront, other research is going to help us as well. None of this was happening in closed thing. So far, we were sharing papers. Can we share the models themselves? Can we share the code for the models, etc.? Right, making that possible, and that's becoming more and more easier over time. We started it way back when. Now, of course, you can see things like Hugging Face and other places, just like GitHub, where people are making things available, and that's really changing. So it's taken a while for all of that to come to fruition, but those were the key ideas. And why should we do it? Why do we build this up?
Right. And today, when in a lot of sense, the approach from OpenAI has been very different for some of the reasons which they believe, right? So they haven't kind of open sourced, which was almost the norm till GPT-3, that any models which were coming out were released. So how do you feel about that? And then what are your thoughts on, let's say, if there was a cutting edge model today, what would be your advice or what would be your view? Should it be open source? Should it be released in a controlled environment like
Yeah.
OpenAI is doing?
Yeah. Look, it's a tricky one. So couple of things there. One, OpenAI in some ways when they started out or when they initially launched GPT 3.5 or 4, they were ahead of all the other models out there. So one, you could argue they had this business perspective of, okay, should we keep it in control, more controlled, so we can be ahead, we can make more money, we can actually build a business around it. You could say the driving force for that, even though they've been established as a nonprofit, etc., their driving force is, okay, I can only build bigger models if I have more money. So having the money is a good thing in that sense, right? Even if the overall, goal continues to be nonprofit. That's fine. Now, the other side of it though is the risk with these models. And we're starting to see that even with the ones that are open source, if you look at what's happening in terms of, what we can do in terms of the good things. Similarly, the bad actors are exploring and using these models actively now for, for example, cracking passwords, for example, for hacking their way into different kinds of systems. And we'll start to see more and more of that over time. So it's going to be a race between a cat and mouse race where, first sometimes this side is better, doing better versus other and so on. And how do you manage that better? So having more control over these models today makes it easier to allow for that. Over time, will and what's GPT-4 or Gemini Ultra today, is that going to be open source? I mean, yes, I think it's a natural progression, but likely after we have better models internally at some point. On the other hand, you can see Meta open sourcing fair number of models. Is that
Yeah.
honestly the best model that they have? Maybe. Like, they're likely slightly ahead of
Yeah.
where Llama 2 is, but
Hmm.
they'll take some time to open source it, et cetera, et cetera. But yes, it does come with the risk. So it, overall, in the long term, I think there's a lot of iteration that's going to happen. Right now, even with the open source things, if you take the biggest models that are out there, it's not like everybody can run them easily. They're still going to run in a cloud, or they're still going to be managed somewhere, etc. So, from a pure usage perspective, doesn't change too much. In the long term, the commercial aspect, yes, there is going to be a play there, but those costs are going to continue to come down because of a lot number of things: market forces, competition, change in algorithms, etc., etc.
Got it. Got it. Uh, and one uh, more question related to this, right? So when you're leading this entire project, right, there are multiple aspects to something like this, right? So community, research, and then how much time and effort goes into, let's say, building the next version of TensorFlow. To
Mhm.
how do you put it on cloud and the applications which are coming there? So as a project lead who is defining the way forward, uh, and then this is something which the world has not seen, and the world is also kind of discovering while it is happening. So, what were some of the challenges or trade-offs which you faced, and then how did you kind of go about addressing them?
Yeah, yeah. Look, I think that's a great question, and you hit the nail on the head in terms of what was the hardest thing. Like, it was really making this trade-offs. It was if you mentioned a couple of them. We had so many different kinds of users, and their goals were very, very different. So, for example, where we started, which was part of research itself in Google Brain, the goal was, okay, how do we push the state of the art? And that needs certain things. They want the flexibility to try out new models. Yes, they also want the scale because more and more of these models were starting to become bigger, so they can't run on a single GPU or TPU or whatever. They want to be able to scale that too. So that's one side. The production side, where across Google, there were tons of applications that were already using this. And they want to be able to deploy these models, whatever the research comes up with, or whatever those teams come up with. They want to be able to not just experiment with them, but deploy them. And Google's been a few years ahead of the typical industry in this regard. Like tons of really, really, significant models have been deployed at Google for a while now. Then, like you said, the community itself, like, okay, what's interesting there? Community also had both the research and the production side, although I'd say production was probably a bit further behind. Research was,
Hmm.
closer to where the state of the art is in some sense, but not production. Commercial aspect of Google itself, right? How do we? Oh yeah, we want to open source it. We want to build this community. Can we monetize it in some way with cloud? And how do you put that? So it wasn't there wasn't one easy answer. uh,
Right.
you know, is there one goal that you can just set? Okay, this is the direction that we should go, and that in some ways was a limitation, and the Achilles heel for TensorFlow. We tried to do too much in some sense. That the end goal was okay with going from TensorFlow 1 to 2 was one, we realized we had focused with some of the design choices, production and scale had been a very important piece. That it seemed like that was going away, that was going to stay, but the usability and the simplicity was more important. And TensorFlow 2 was a direction to try and help with that. I think we started in the right direction. I don't think we've executed, in lots of ways to where that should be, but
Mhm.
that's sort of how we were thinking about it. From the monetization perspective, of course, uh, in some ways, good or bad, I was partnering with the cloud teams to help monetize that, etc. And so enabling them in different ways, etc., was important. But it wasn't a deep partnership in where we, built things out there ourselves, etc., which perhaps a closer partnership would have helped.
Okay, okay, got it. And then, after this, you at some point decided to venture again on your own and then start Inference.io. And the vision was to bring intelligence to BI, right? So can you share what was the uh, key problem, the trigger, and then how did that?
Yeah. So two sides to it, right? One, I've over my career, I've been at lots of startups, so lots of early stage companies, mostly as an engineer. Although the last company uh, I helped the founders build out the eng team, etc., and build the product, etc. I always enjoy building things from the ground up. The TensorFlow experience and this brain experience was also similar in that we started something from the ground up and built things out. That was fun. So that was sort of one side. In terms of the problem itself, one of the things I noticed, and one, ML was coming off age where we could apply it to lots of interesting things and actually see value. So the question was, okay, which one makes more sense from where I'm coming from? This data problem is something that I saw myself firsthand as well, which was, there were a number of cases where, again, TensorFlow was open source, but we had some metrics for that, right? Our metrics were like number of downloads, for example, or the number of users that are coming to the website, etc. And there were significant changes, as an example, like the downloads went up significantly one day. And I spent some time figuring it out what all the dashboards that we had to no avail.
Mhm.
I asked an analyst to look into it, still didn't get any answers. Thankfully, these were the good times, and those numbers kept going up still. And we're like, okay, fine, let's forget it and let's keep going. But that's just one
Right.
example, right? I mean, things go the other way as
Yeah.
well. I've seen the same thing in ads as well, where metrics sometimes there's a fluctuation and you want to know what's going on. And in fact, sometimes you take weeks if it's small enough. It happens in a small country. We not notice for a couple of days until that country manager or somebody notices it and tells you about it. So how do you figure those things out? And so this was something I'd seen, talked to a bunch of folks, realized that yes, this is a real problem. Lots of people face that. So decided to jump in and see, think about can we solve it? Had some initial ideas, and then decided to jump out and explore more, and then started to build the company around that.
Interesting, interesting. And while you were kind of building this, was it, going back to make the product more real time and accessible, or was it, including some of these, let's say, vision and maybe text capabilities to kind of accelerate the discovery of these points? So was it that the information would be available more seamless, or was it that the discovery has to be accelerated, or maybe both?
So much more the discovery side of it,
Mhm,
also allowing people to, and I'll go in a bit deeper on that, allowing people to put in more data because now they don't have to look through it manually. We didn't start
mhm,
with different or unstructured data like images, etc. The long-term thing was, yes, we can add that in because we can extract interesting things from there and then apply similar techniques there as well. But we started with this whole idea that, what, today there's a lot of work that goes on in building dashboards because some user wants it this way or that way, etc. Because that's how the only way for us to understand data is not by looking at the numbers. I can't look at a spreadsheet of numbers and understand what's going on. But a simple chart helps me understand that a little bit. Of course, the chart is it's two dimensional, but it's usually a single line or a few lines on a board. There's only so much you can get. The data has hundreds of dimensions, maybe at least tens of dimensions. So to understand that, either you need like tens of charts or hundreds of, I mean, literally, if you look at all the combinations, millions or billions of charts, which obviously you can't look at. So you look at a handful. How do we look at all those essentially from in an automated fashion to figure out what's important? How do we help people understand what's going on? So to give you a very simple example, building on what I was saying earlier, often what happens is, let's say I'm tracking, some key metric for my company, revenue, and let's say I'm an e-commerce company, etc. I want to see that revenue is going up, everything's going well. As a GM, I'm looking at these numbers every day. I mean, I see there's a drop in the number. I want to figure out what's going on. I'm going to just ask somebody, go figure it out. But half the times, this is literally, that's what happens. They spend half a day, no answers. They're like, hopefully it'll resolve itself. Often enough, it does that. They're like, okay, you know what, it's okay. But the underlying problem is just pushed out for the next time, not really gone.
Yeah.
In our case, what we're trying to do is, you know what, you don't need all that. Point us at the data, tell us what's important to you, like revenue, etc. We'll tell you, okay, oh, there's something happening here that's a problem. So A, that's important for you to look at today. B, oh, you know what? This is because there's a problem in this specific area. Like in this case, maybe Kid Shoes in New York is having an issue. You need to go take a look there. In fact, we can also go from there to say that's down because the traffic in that area is actually down. And that traffic is down because you're not getting enough traffic from Facebook this month. So really connect the dots and get them to the problem so they know the right people to solve it, the right things to look at, and save tons of time and not spend their day on random things that don't matter.
Interesting.
And this is just
And
one example of how you.
right. And you were doing this journey probably at the times which were non-representative of anything the world had seen, right? So you started it probably during the COVID time, and then uh, uh, was COVID a boon? Was it a challenge? And then how did you navigate that time?
Yeah, it was a yes, it was an interesting time. It's definitely not something that we've seen before. Hopefully, we won't see at least not
Yeah.
for a while. Uh,
Yeah.
but the it was interesting in that look, I started so early 2020 was when I was about to start, and actually started finalized the things by March or so. By the time I was like, okay, let's go get started, let's raise some money, get the team together. Basically, COVID was here and everything was shut down. So
Right.
everything I did was online. Things, I mean, it's not like we hadn't done video conferencing before, but making key decisions on who to hire, who to partner with. Me and my co-founder met for the first time online and spent a whole bunch of time talking through things before, actually meeting in person. In fact, also because he wasn't even in the Bay Area, so that just made it harder. Talking to the VCs and talking to people you've never met before. Thankfully, I'd met some of them before and knew them a little bit. But for many of the people who you're meeting for the first time, and helping them understand, it's a hard thing from the other side if I look at it from their perspective as well, where how do you build that relationship and trust without meeting? No, but we had no idea. I mean, now we have a better sense and we can do it better, perhaps, but it was just
Right.
hard. So it took a little, took a while, took that entire summer to figure things out and get things in place, etc. And we finally got started late 2020 and started to put things in place. It was also a time from a hiring perspective, at least the early days. People didn't know what was going on, so nobody wanted to take that risk at that point. They're like, okay, you know what? Let's just keep things stable. There's just too much uncertainty out there. Um,
Mhm.
the next year was better from a hiring perspective because by that time things had settled down. People were getting tired of the big companies, so they were more willing to come out, etc. So from a hiring perspective, that had turned out to be well. Um, we it was also a great year to be selling the product because people are willing to invest in tech, etc. But
Right.
we weren't quite ready yet, so we took most of 21 to sort of build the product out, and we were just working
Mhm.
with a few folks by then. So we we were too late for that win in some sense. But so we went through challenges. I mean, startups have challenges, of course.
Mhm.
It's but yes, it was interesting. This one was definitely a unique time.
Interesting. And during this, right? were there thoughts about building a community or open sourcing some version of the product so that you could have a B2C arm or self adoption to some degree, or you were entirely focused on enterprises or a few startups which could kind of test the product and then build from
Yeah. So, couple of things. In this case, because the product was so data focused and we needed, whether it's the models or the algorithms, they needed to be tuned, we needed real data to be able to build them out. So the early things were with customers or, usually mid-sized companies, couple of enterprise companies as
there?
well, that we were working closely with to build the product out itself. But the goal was that, okay, once we build this out, we want it to be simple enough that anybody can start and use it as well. In fact, we ended up shutting it down last year for a number of reasons. Happy to go into, but one of the later things the goal was, and we had built eventually, was anybody can download this. So there's a container, just come and download it out. You can run it on your data at a small scale yourself, try it out completely by yourself without having to worry about either giving access to your data or any other thing. You can just take it, run it yourself, and then sort of iterate from there. Our initial version of that was, okay, you can do that the same thing in the cloud where you connect to our cloud, connect your data, let's say your Snowflake account or BigQuery account, and you can run things. You can try it out for a month for free. So sort of build a community around that. That turned out to be harder because the access to data was limited. Not everybody could share the data, even though we got the standard security things. So that's why we started to move toward a model where it's yours essentially. It's not open source per se because there was some IP there that we didn't want to share. We weren't quite ready,
Mhm.
but you can still use it for free.
Got it. And you mentioned that there were some of the reasons and learnings in the journey. So can you share some of the reasons why you kind of took the call? And then obviously it would have been a very difficult call in that sense, right? What was the driver, and then what were some of the reasons?
Yeah. So look, the at the end of the day, this early stage, the biggest thing that you're trying to get to is a product market fit. And what does that mean? That means that and some people call it a product market sales fit, which is here's a product, there's a market for it, as in there's a need, people want it, and they're willing to pay for it, and here's how they're willing to, how that process might work, etc. Um, was there a need for it? Yes, we talked to a bunch of folks when we were starting out,
Yeah.
and people were very interested. But over time, what we realized was that need was, I mean, yes, there's a problem, but people are just used to doing things a certain way. And if they think about what's the top problem for them, for a lot of the folks, and in this case, the person we were selling to was the head of data or the head of analytics, etc. This was not one of their top problems. There might be others in the business who care about this more, but at least not that person. So now, is there a person you can find for whom this is a big problem, etc.? And that comes to the go-to-market and the sales side. We hadn't figured that out yet, so that we hadn't figured that fit yet. From a product perspective, is there value, etc.? Yes, but that's only part of it, right? Until you can figure out all the pieces of how does it get into the door, who wants it in what way, etc. It's hard. Now, in some markets where the market's going, for example, even 2021, where people were throwing money on the tech side, it's easier to kind of continue and explore things more easily. 2022, 2023, there was talk about recession coming, etc. So nobody had extra money to throw at something that they were not really completely convinced on. They
Mhm.
might be interested, but okay, I'm spending 100K already. Am I going to spend even 20K more, right? Forget like
Yeah.
100K. It's a hard one to get, and the CFOs are not going to give you the money, etc., etc. So that just changes the equation. Getting to be in a place where, as they call it, is it a vitamin or a painkiller? In this case, it felt like a vitamin to them. It's not a painkiller because they are getting by without it. basically, right?
Yeah.
So that was one. The other was the there were things that we could do in terms of just like you said, right, going more bottoms up in terms of people trying it out, building a community. We were heading in that direction. That was always the goal, but without enough support from okay, yes, there are these end customers that are already using it, and we have the product, and this is how we're doing it. It was just hard, and by the time we got around to it, in some ways, we had already spent a lot of time building the first pieces out. So now the question is, do you still try that out? It's going to take a few years to figure that out. And there's no guarantee still, obviously. You still have all the risks that you've
Yeah.
talked about from their perspective. Given that we saw people don't see this as a painkiller, it made that harder to say, you know what, yes, it's going to work this way. And there were, I think from a, if I think back still from a direction and a vision perspective, is that how BI should be done? Absolutely, yes. At some point, we need to get there. What we couldn't figure out and what I couldn't see was what's the path to get there from where we are today. And with no path in mind, I mean, there's only so much exploration that you can do. And it just didn't feel like the right thing to continue to have the team push on, groping blindly through tons of things when we have, no clear idea, etc. Um, Things were also, yeah, the other side, and maybe, the AI side was last year was gaining a lot of momentum in terms of, okay, yes, people want to use AI, etc. But their expectations for that were very different. Their expectation was the chatbot is the interesting thing, not necessarily AI doing something under the covers.
Interesting. Yeah. No. No, it is one of those behavioral challenges you come across because this problem exists in almost every analytics setup, right? You're not able to get to it. So it is at least as a data professional, when I see it is clearly a pain which needs to be resolved. But yeah, if the decision makers are still not there, it is one of those behavioral conundrums in that sense. Uh, if someone was to, let's say, take a shot at solving this problem today, anything which you would recommend them to do differently? So maybe ChatGPT becomes the kind of first player, or any other idea. So let's say if I am a data professional with 10, 15 years of experience, and then I want to today think about building a product which transforms BI as we experience it today. Any leading thoughts which you would have?
Yeah, one go narrower, I guess. In
Hmm.
some ways, because our technology allowed us to be general, we kept staying as a platform almost like. Instead, if you go more either vertical from a industry or a function perspective and more focused, that might help.
Mhm.
Think about the user. It doesn't have to be the particularly a bottoms up approach might. In this case, I would say is I would bet on that way more than a top down approach, just because of how people think. But there, who is that user? Who is the person really thinking about it, putting yourself in their shoes? Are they willing to try this out and get things going? Uh, the last big one that really worked out was Tableau, which grew bottoms up. Uh,
Mm.
Looker wasn't quite bottoms up, and it did well, but it took a while for it to get there. Uh, and in this industry, at least, it feels like that direction seems to be much better. I think products wise, the hard bit will be there's a glut of products in this space. Everybody wants to go after it because the problems are there. Like you said, right, as a
Yeah.
data professional, you see tons of problems. I mean, this is just one of them. There are other problems as well.
Right.
That said, that glut doesn't help each individual one because it's just one in many. Now, at the same time, on the flip side, when we were talking to these customers, it's not like they're comparing us to A, B, or C as a like a new company or whatever. They're comparing us to what they're using today, Tableau or Looker,
The incumbent.
and they're how do they change? Like, there people are getting more ready to change with Tableaus of the world, particularly. I think they're and happy more and more. But it's
Mhm.
still a big change. How do you
Good.
support that change, right? What really triggers that?
Interesting. Uh, I went through some of the posts you've written and shared on Substack. Uh, for you, how does writing work? So do you go through the thoughts and then writing is a way to communicate it, or it's a way to reflect and improve the thought process? So do you think and then write, or you're writing and kind of thinking and sharing?
Yeah, in my case, I would say more the former in that I write to communicate.
Hmm.
Although I've been exploring and experimenting with writing to clarify my thoughts as well. Uh, I just like to, like, just how I function so far. It's been, I like to read a lot. So I read all kinds of things and slowly let that sink in and iterate on that. I'm pushing myself to write more to actually clarify some of those thoughts, like you said, right? Uh,
Hmm.
so starting to head in that direction, but I would say I'm still so far more on, okay, here are all the things. Let's see if I can put them together in a reasonable way to help somebody else understand. In the end, of course, it helps me as well because yes, that clarifies things. Let's focuses on maybe I'm thinking of 20 things, but only three are important, and these are the three. In fact, there are so many of these things where uh, I start a post and I'm like, you know what? No, I mean, it makes sense as an idea or whatever, but it's there's nothing like coming new out of it. It's just a collection of okay, these three things that I've read together. So do less of that.
Yeah, yeah. And one of the recent posts which you did, which is about the 1000x gain in computing, which we have had in the last decade or so, right? And then I think again, brilliant summary of where we stand today and in the gains we have had. And then one of the questions you're asking is, in the next decade. How we are still not clear how would we see, let's say, that kind of magnitude. And I just wanted to kind of ask, so isn't it the case that it is always difficult to kind of predict this looking forward? So 10 years back, if I would have asked you that, what would be the magnitude you would have seen, my sense is you would not have predicted 1000x. Or you actually feel that the pace we have seen in the last decade is unsustainable, and then we would probably see some troughs, and then that's where the question is headed towards.
So a couple of things I think. One thing that was clear even yeah maybe 10 years ago that if we have 1000x more compute, things will get better significantly.
Okay.
The models will be better, they'll be more powerful, etc. Did we know exactly how? No, but like if you ask people in the space, 9 out of 10 would probably tell you yes, if they're much bigger, it'll be better. They might not have a more clear
Right.
scaling law or whatever, but it was very clear. So there was enough impact that this space was having that there was interest in making that happen.
Mhm.
It wasn't clear how to do it. Absolutely. Like you said,
Right.
right? Looking
Yeah.
back, it's easy to say this is where it came from.
Yeah.
Now, so looking forward, can we say this is where it's going to come from? It's going to be super hard, right? I don't think we
Yeah.
can nail down exactly where this 50x or 10x or 2x or whatever. The ones I put in the post were more learning from the past, and there's some areas
Right.
that are not as explored. For example, sparsity is just one of them. That happens to be my favorite one as well. But I don't know. I have no idea if that's really going to make it in, especially in the next 10 years, maybe in 20 years, maybe not at all. Some of that is going to be driven by what's the people are exploring and trying out lots of different ideas. Traditionally, it was like, okay, yes, Moore's law is going to help us significantly in case of CPUs. It continued to help us, so we didn't have to worry about so many other things. That's gone now. There's no standard approach where this is definitely going to, we know that it's going to give us so much. So now we have to explore and come up with new ideas, etc. Again, there are few in the directions that we've already gone in. For example, like quantization, we've gone to 8-bit. In fact, there are early experiments showing even 1-bit works.
Yeah.
We don't have the hardware to leverage it. So one thing would be let's just try the hardware and really push the things on those, right? Those are some of the easier ones. Some of the harder ones will be sparsity, for example. It's not yet clear that how well it's going to work, etc. Can we come up with newer models, etc.? Can we come up with different models of computation? And that's a tricky one in that, look, the good side is there are a lot of startups trying to compete with NVIDIA, which is like by far the leader. Everybody is buying things. I mean, you see the stock going up like crazy for good reason. I guess they're selling a lot. The NVIDIA doesn't have too much incentive to change the model completely because that's not their business. I
Yeah.
mean, that would be a very, completely a new experiment, right? And they might try,
Right.
but it's a much harder thing for them to do. Just like it was very hard for Intel to get into the
Intel.
GPU business and others, right?
Yeah.
Now, of course, Intel's over time bought companies like Nirvana and Habana more recently, and so on, and that's fine. That'll continue. But if you think about the startups, they can't beat NVIDIA at NVIDIA's game. They can't build a better GPU than NVIDIA, but they can build different systems, whether you call it a TPU that Google did, or an LPU that Grok is doing, or something else, which have slightly different choices that they're making in terms of building the board, or even Cerebrus, which
Yeah.
built a completely different, like a wafer-sized chip, right? Not
Right.
all these experiments, in fact, most of these experiments will fail, but it's possible that one or two will actually make sense and they will really push the things changing. The good thing is there's interest because we're seeing that there's so much demand for hardware, right? Just
Yeah.
knowing the models that we have today, if you take GPT-4, then you take that from the data center and run it on the phone. That'll be pretty amazing. I mean, what we can achieve is going to be very, very different, right? Each of us can have our own model that perhaps continues to train, perhaps continues to optimize for us. The kind of things that are enabled are just going to be so different. And we are seeing that there's clear value from that. Things are going to get better, but even ignoring all that, there's so much value that there's lots of incentive to optimize for that. So there's interest in doing the 1000x. There are lots of smart people working on it. Interest both from a mental perspective or whatever, but also monetarily. And so put those things together, the likelihood of that happening goes up significantly. Are there some real challenges to be solved? Absolutely. I mean, both, like if you go down to hardware, there are lots of scientific challenges. From an algorithms perspective, can we go from what we're doing today to like even going to a single bit or going to very sparse models? It's different ideas on how to make that work. People are exploring completely new. Transformers is this thing that we've tried out for the last 5 years, seems to be working great. People are exploring newer ideas like Mamba and others like state space models, etc., which might be interesting, right? And they're close enough to transformers where you couldn't say that yes, it's a completely new thing,
Yeah.
but they're helping, right? So how do you iterate
Right.
and get those things better? So overall, we'll see a bunch of those things, but is are we going to get 1000x? I don't know, but I would say that's the goal that I see us putting to forward. Even if we get to 100x, that's still going to be a huge win. Are we going to get the 10x? Absolutely. Like, I would, if I were a betting man, I would say at least 100x over the next 10 years, perhaps even more.
Yeah. And when you look around in the valley right now, and with so much action happening and then buzz around generative AI, what are some of the themes or trends, or let's say which you would see playing out in next few years? What would be some of those things according to
Yeah. Look, short term, what we're seeing over the last year and this year is there's starting to be a bit of a hype. I mean, is there
you? Yeah.
real stuff? Absolutely. I mean, these models are amazing.
Yes.
What they can do is amazing. There's a bit of a hype because everybody wants to use them without really knowing what to do with them. Like if you think about the
Correct.
enterprise, at the end of the day, I mean, Silicon Valley is about building these companies, etc., that are eventually going to sell to somebody, and that somebody is usually the enterprise, right? Today,
Right.
they are you see a lot of these companies selling to other startups, which is often not sustainable, especially in this kind of a time.
Mhm.
Enterprise is definitely interested. Enterprise is putting a lot of money in this area to experiment. we don't know where those wins are going to come from, really. And we are still, we have some early things going on. How does it translate to real use cases, et cetera? That's going to take a little bit longer. And so that, that spike that we are seeing is going to go down. Is it going to be higher than where it was before? Absolutely. I think we'll have more enterprises using AI over the next few years than they were before. But that will sort of, I think over the next couple of years, we might see a slowdown in some sense, right? Especially in the money being thrown in some of these companies, et cetera. That said, how do you go past that? How do you, figure out real business models, etc.? Today there are 20 infrastructure companies or picks and shovels, as people call them, right? Uh, Not everybody's going to make it. And how do you get the right things out? How do you make things continue to work, etc.? We'll see more of that, maybe a bit more consolidation in the next couple of years. Probably another year or so out, because the people who raised money last year have money for a couple of years. So, at that time, we'll see some changes. Um, the general idea right now seems to be there's, money at the bottom where, there's the picks and shovels, as you call it, right? The infrastructure in some sense, which is public clouds, but there's more. What else there? People helping use that stuff. And at the top, can you have applications where people can actually solve problems for you that lots of people can use? Uh, that application side, solving real problems, etc., is harder beyond the first wave that we saw, where, oh yeah, we have this application, take an example, Jasper AI, it'll write stuff for you, right? It'll write marketing content for you, etc. Now everybody can do it just themselves with ChatGPT subscription or whatever else. So that differentiation is gone in some ways. But there's clear value there beyond from where we were, right? Coding, again, the developer productivity has improved. Those have been early wins that we are going to see. We are seeing and we're using. So that usage will go up over the next few years. Uh, we hope to find more applications, I think, and we'll probably see some more coming up that work well, and that iteration would be interesting. There's this whole idea of agents doing more stuff, actually doing stuff, not just doing things, which is promising. I think I see a lot of companies in that space. I think that's if they can make it more real in terms of people starting to use it and it showing that value, that'll be interesting over the next couple of years as well. It'll be exciting to see more of these applications solving real world problems and changing each of these areas one by one. In some sense, it's not going to be like, okay, here's the model, you figure it out. Like figuring out will be done by startups that make real
Right.
things that are use.
Interesting, very interesting. Uh, Rajat, towards the end of the show, we ask a few rapid fire questions with our guests, right? And the idea is to just know you better as a person. And so these would be very short questions, but I would love to hear your whatever thoughts come to your mind, right? Uh, what are some of the books which have had like the greatest impact on you, and what would be your recommendation on some of the books?
Yeah. So most recently, look, the last year I've had time since close sharing on the startups. I've read tons of books. The ones that
Hmm.
I would say enjoyed the most, I particularly focused on science fiction, and I've really enjoyed Asimov, the
Okay.
I,
Hmm.
Robot series, etc. Really loved them, and the Foundation series as well. I think the
Hmm.
way he's presented both the thoughts on robotics and AI in some sense, because these robots are human-like in so many ways, and also the Foundation series in terms of how the civilization moves forward and does different kinds of things. It's super interesting, and I think if I think of near term, those are probably two ones that really made a difference that I would recommend to
Right.
everybody.
Yeah. And during your career, did you consider going back to research at any point? And then, what was your kind of thought on that?
Yes, actually a number of times. So initially, in fact, after college, I was really done with studies. I was like, okay, you know what, I can't take it anymore. I barely got through 4 years.
Hmm.
Um, so I wanted to go work at a company, etc. Tried Infosys, another startup. It was fun in that I was learning a lot to do things, to build things. But I thought I wanted to learn more and go deeper in some areas. And so I did consider doing a master's, applied here, didn't get anything interesting, and so that never worked out. Then afterwards, in some sense, I kept learning on my own and read things. In some ways, I could say, just when I joined Brain, etc., it was you know, a bit of an experiment with doing research as well, right? This was a very open-ended thing. It was really a research project, at that time. We were working with researchers, of course. In fact, most of the people around me for the longest time were just PhDs who had done
Right.
all kinds of different things. Most people had, actually, we had half systems and half ML folks. So I would say a mix of those. So ended up learning a lot from them. So in some sense, it was that research, and I continue to read a ton of papers and enjoy that. Just haven't done
Okay.
a formal program of, okay, yes, here's a PhD, go focus on that.
Interesting. And for people who are, let's say, starting their career or are very at a very early stage, right? What would be your recommendations to them, let's say, in terms of startup versus working at corporates and research versus applied, spending time in applying those technologies? What would be some of your recommendations?
So each of those choices are good. They're different. It's not like one is worse than the other. You learn different things. At a startup, and one thing I would say early in your career, try out different things, right? Don't be hesitant. What's the worst thing that'll happen? The startup will fail, you will fail. It's okay. You will go on, you'll do something else, and that's okay. Make sure to learn from those. Each of those things is a learning opportunity. What you learned in college in the 4 years, that's the very beginning. I mean, this much. You have to learn a lot more. And
Yeah.
the only way to succeed is to keep learning. That can be in a formal program where you go deeper, let's say a PhD. For some people, that's the right thing. Going back, I would say it would have been a fun thing to do, but again, the people are at different times. The right thing is different for them. The that forces you to go deeper and be able to think deeply about certain problems, and that's value because that allows you to make a bigger change, like actually solve bigger problems. Solving big problems does take time. It doesn't happen overnight. You can solve little problems. You can build an app in a day. You can't solve a big engineering problem in a day. That is going to take
Right.
time. So be patient in some of those cases. But pushing the boundaries of things is good. Continue to learn. I mean, just that's sort of number one if I were to think about it. Keep learning all through.
Got it. And how? What's your style of working? So, are you someone who would, let's say, block 3 hours and then go deep, or you would, let's say, have 25 minutes of time with breaks in between? So how does your style of working look like?
So I think that's varied over time as well. For for example, when I'm working with a larger group, when there are lots of different things depending on my role too. For example, at Google with TensorFlow, with a huge team, lots of different things going on. I had to be involved in different ways, right? I mean, sometimes it's just talking to one person about it. Sometimes there's a meeting on discussing things, in which case it's very like, okay, 30-minute discussion about this, then 30-minute discussion about the next topic, and so on. Yeah, right? You're iterating. You don't get the longer chunks. It's harder to do that. Or thinking about harder things where, okay, I need to solve this problem. For example, this startup was, you're trying to do this. We wanted to figure out, okay, what is that differentiator, right? How do you think about it? Solving that problem, understanding the problem deeply. That takes a lot more dedicated time. And it's helpful to do that. Like these days, I'm reading a whole bunch of papers about specific areas. So let's say, quantization for one. If I'm looking at that, I, think about some things, maybe look at a paper or two about that. That would take like an hour or 2 hours or whatever, right? Until it also depends on how long you can focus, right? Sometimes go for a walk because that just helps clear your mind, etc. So it's a mix. It's not like one size fits all, but thinking deeply and doing, solving bigger problems does take time, and so that fixed time in terms of where you can spend so much time just doing that is definitely.
Great. And then just one last question. What does a typical vacation or weekend look like for you? And then what are some of the hobbies or places where you spend time?
Yeah, so weekends are usually with kids, mix of just playing all kinds of things. I have two kids, 17 and 10. 17-year-old is, of course, much different. He's busier with his work and stuff as well. Try to spend time, do different things. Sometimes it's just doing little things like crosswords or just little games, or just playing around the house. I do like playing pickleball. I mean, that's the nearest. Always like
Oh,
some sport, and pickleball is just
right.
the most recent iteration of that, I guess. And so
Mhm.
do that once a week at least if I can. And lately, this past weekend, my daughter was up for playing with me, so we played a bit. My wife, and my daughter. So just doing little things around the house. Vacations, we like more relaxed ones. So usually beach kind of vacations, or just where we're not no big plans. Yes, we go
Right.
someplace. There might be a couple of things we want to see, but then just chill out, enjoy the food, just do what we feel like that day.
Great, great. Thanks a lot, Rajat, for sharing those insights and sharing your journey and tremendous learning, tremendous things to be learned and so much perspective. So thanks a lot for sharing that and sharing that openly with the community. Thanks a lot.
Yep. Thanks, Kunal. It was great to be here, and always good to talk to you.
Yeah, thank you. Thanks, Rajat.